Okay, so welcome back, and we're only going to talk about the uniform distribution in this chapter. However, this chapter also discusses the exponential distribution. The exponential distribution takes the form x is a exponential expression with respect to m, which is given here in this curve, and it's good reading. I highly encourage you to do it, but we'll not be studying in this chapter, so we can skip this for right now to move on. The other kind of continuous probability distribution we'll be discussing is the normal distribution. The normal distribution is going to be studied in detail in Chapter 6, so we'll skip this for right now. And let's move into an example, I think, that will illustrate the points that we've been making about the uniform distribution and give you some background in order to handle the homework. So in this example, the bus N60 passes a certain bus stop every 30 minutes during the week and is typically 0 to 6 minutes of the scheduled arrival time. We are interested in the time a commuter must wait for the bus to arrive at the scheduled time. So the time follows a uniform distribution. Well, first of all, let's use our notation appropriately right here. Our first question is, well, what is the appropriate notation? Well, we're going to write it this way. X is a random variable, and the distribution of that random variable, we use this little squiggle right here to represent that, is a uniform distribution, so we use U, on the interval from 0 to 6 minutes. Well, that's it. That's our appropriate notation. That's how we write that out. Be careful to ensure that we indicate the correct notation for the type of distribution as well as the values of A and B within this distribution. What is the probability density function? And let's sketch a graph. Well, the probability density function, remember, we find by using our formula. Come on. I've got to get my pen to cooperate with me right here. So the probability distribution follows the form f of x is equal to 1 over b minus a. So in this case, a and b are equal to 0 and 6. So our function is going to be 1, 6. What that means is that we're going to draw a horizontal line at the level of y equals 1, 6 to represent that function. Now, the variable follows on the interval from a to b, so we can only consider this function on the interval from 1 to 6. So we stop right there. It's from 0 to 6, and we stop right here at this point. And so we draw what looks like a rectangle to represent that probability density function. Well, here's the next question then. If we have that, what would be our mean and standard deviation? Well, the mean and standard deviation are found using the two formulas. Remember that the mean, mu, is equal to b plus a divided by 2. So we take the sum of the two endpoints and divide by 2. And to get the standard deviation, we're going to take the square root of the difference of b minus a squared divided by 12. So making the appropriate substitutions into our formula right here, our mean is going to be 6 plus 0 divided by 2. And we know that 6 divided by 2 is equal to 3. And so our mean, well, this makes sense right here, has to be at the midpoint of our standard deviation, which is 3. That's good. The midpoint of our distribution. Our standard deviation is going to be found as follows. We're going to make the substitutions in for b and a. So we're going to subtract 6 minus 0 and square that number and divide it by 12. The square root of 6 minus 0 squared is 36, by the way, and we divide that by 12 to get 3. So our standard deviation is the square root of 3, which is approximately equal to 1.73 if you brought out your calculator to check. That means that if we went 1 and then 0.73 more, or thereabouts, we'd be 1 standard deviation to the right and 1.73 to the right. So this is plus 1 standard deviation and minus 1 standard deviation. All right. So those will be important to us later, but for right now it's good to understand what these things are. Well, here's an interesting question then. What is the probability that a commuter must wait somewhere between 3 and 5 minutes for the bus at the scheduled time? So what we're looking for in this case is the probability that X is going to fall somewhere between the 3 and 5 minute range. And the way that I said that we should do this with our cumulative distribution function was to take the difference of the probability that we have to wait up to and including 5 minutes minus the probability that we have to wait up to and including 3 minutes. Right? And geometrically, that should make sense, right? Because if you imagine our cumulative distribution all the way from 0 to 5, and then we take away the area that's under the interval from 0 to 3, we're going to have our probability under the curve here. Right? We're going to call that P. So what will we get? Well, let's figure it out. We said that in our cumulative distribution function, I'm going to write this up here. Remember that the CDF was given by the probability that X was less than some value C, right, is going to be equal to the difference between X minus A divided by B minus A, and then of course we would put in C for X and figure out what that was. So in our case, when we do that here, let me bring it back to the right color, our probability is going to be 5 minus 0 over 6 minus 0. And the probability that we're less than 3 is going to be 3 minus 0 over 6 minus 0. Subtracting that gives us 2 out of 6, which reduces to 1/3. So we're saying that there's a probability of 1 out of 3, or 1 out of 3 commuters will have to wait somewhere between 3 to 5 minutes for this bus to arrive after its scheduled time. Well, one more example here. Let's figure out how much time must 70% of the commuters wait for this bus? Well, what we're really asking is to say, well, all right, there's some time here, probably right around here, maybe, I'm guessing. There's some time X that represents the probability that 70% of all the commuters must wait. What is that time? Well, again, using our probability distribution function, what we're trying to find is some value C such that when we take the value of all the times less than that, we get 0.7. Well, what is that? In this case, that means C minus 0 over 6 must equal 0.7. Well, to get this, we're going to follow some algebra, right? Multiply both sides by 6. So C divided by 6 times 6 will equal 6 times 0.7. In algebra, remember, we multiply both sides of the equation by exactly the same value. It leaves the equation unchanged. And in this case on the left, 6 is canceled out, so we're left with C equaling 6 times 0.7, which becomes 4.2. So 70% of the commuters must wait somewhere about 4.2 minutes, which is 4 minutes and 12 seconds or so, in order to catch this bus past the scheduled time. Well, given that's the case, then what percentage would have to wait longer? Well, actually, that's not a hard question to answer. In this case, if we're interested in the amount that have to wait longer, the best way to think about this is that whatever percentage was less, we subtract from 1, right? So the probability that the commuter has to wait more than 4.2 minutes, so the probability that X is greater than 4.2 minutes in this case is going to be equal to 1 minus the probability that X must be less, which is 1 minus 0.7, which is to say 0.3. So the answer is that 30% of all these commuters will have to wait longer than 4.2 minutes in order to catch this bus. Okay, well that's it. So don't forget that the assignments due this week by Friday. Make sure you have watched the Chapter 5 lecture and completed the Lecture 5 form on Google. And then complete the Chapter 5 web assignment homework by Monday of week 6 and post to discussion board 3. That's it. Have a great week, everybody.